Hello and welcome to my tutorial on how to install NCBI Blast on a Windows machine. Now, by being here alone, I assume you know what Blast is used for. Now, a page on the NCBI website defines Blast as a suite of programs provided by NCBI for aligning query sequences against those present in a selected target database. Now, if in addition to this you need further information on Blast, I refer you to this website. Now, why would you want to install Blast on your machine? Now, if you're running standalone Blast, which is the name given to the one installed on a local machine, you don't need internet connection because you're not querying sequences on the NCBI server. You're querying sequences that you have on your own system. So everything works offline, and there's no need for internet connection for that to work. And because you're not querying sequences on the NCBI server, how busy the server is will not really affect the speed at which your Blast runs. So everything will depend on your own computer hardware and not how busy NCBI server is. If you run the online version of Blast, you would notice that during certain hours of the day, Blast gets really slow, and that is because the server gets really busy during those hours. If you're running a standalone Blast, that doesn't really affect you. Now, compared to the online version, the standalone Blast is entirely a command line based program, so there is no graphical user interface. Everything works here. You need to type the commands in a text format. And what this means is that you need to be comfortable with working inside the command prompt. Now, in this tutorial, I'm going to show you how to install the Blast programs, because Blast consists of, as mentioned in the definition, a suite of programs. So there are a number of programs that come with Blast. I'm going to show you how those programs can be installed, and then I'll show you how you can set up a database that you will use as your reference database, which means that if you provide a query sequence, it is against this database that your query sequence will be aligned. Now, the first thing we need to do is to see how the programs can be installed. Now let's go to the NCBI website, the home page, follow the download link, FTP. We look for the Blast folder. Executables. Blast Plus. We want the latest version, so 2.8.1 will work for us. If you want any of the earlier versions, you can download the one. Now, from this list, this is the one we want, Win64.exe. So it's the Windows version, and this runs on a 64-bit computer. So running, if you're going to run Blast on a Linux machine, this is the one you have to download, and for Mac OS, this is the one you have to download. But for us now, this is the one we're going to download. By clicking on it, the download will start, and I have it already downloaded into the folder where all my downloads go to. So this is it. To install it, all you need to do is double click. We say yes. Agree and install. You can close now. It's complete. You can open the command prompt by simply going to search CMD, and it comes up. Opens up now. So to test if Blast is installed, you can simply type blast n dash or -h, and you get help message here, and it tells you that you're running 2.8.1 version, which is exactly the one we downloaded, 2.8.1. So everything is great now. We have installed the program. Now the next thing that I said we would do is to set up a reference database. Now these reference files are already pre-formatted for Blast, and you can download them from the NCBI website. So from the page where we got our executable, we can go back a few folders Now once we're here, we'll go to DB, the database folder. Now the list of files you will download here depends on what you do, and I often run nucleotide search, so I'm going to look for the database files that start with NT, which stands for nucleotide. So from here all the way up to 69, these are the files I need. The MD5 version of each of the files is just to help you verify if the file has not been altered. So we will not need to download them. You can download them if you want, but I don't download them. So you will download nt00tar.gz, nt01, like that, all the way up to 69, and that will give you the complete database. And once you've downloaded, you can put them somewhere in your downloads, or you can create a nice folder called Blast, as I have done, and put them all there. You see, I have them all here. They are zipped files, so they are archived and zipped files. Now, to extract the files in them, you can first unzip using 7-zip, and then after you have unzipped, you can then open the archive using a program like WinRAR. Now that will open the files, and let me show you how the files look like. So for the first one, the nt00.tar.gz, these are the files that you will find in the archive. So you copy them and put them in a folder that you can create called DB. So inside the Blast folder, you can create another folder called DB, and there you put all the extracted files. So I have them all here from 0 all the way up to 69. I think I don't have the complete 69. I have 47. Yeah, but you need to get everything, the full database. which is 0 to 69. Now once you have done this, downloaded them, extracted them, and put them in a folder called DB, what we need to do next is add the address to these files, take the address to these files and add it to the path. So this address, d downloads blast db, we need to add it to the system path. To do this in Windows, you can go to Control Panel, System and Security, and then System, Advanced Settings, Advanced System Settings, and Environment Variables. Now you can click New. You want to add a new path. Now all you need to do here is inside the variable name window, type blast db, and inside variable value type d : /downloads /blast /db . You can see I've already done it here. Now if I say OK, or save it, it will overwrite the old one. Let's see. OK, yeah, because it's already there, it cannot make a duplicate, so it's there. You will not have it, so once you say OK, it will be added to the paths here. The next thing we need to do is to press OK and OK here as well. Now we can close the control panel. So after you've done this, I'll say you're done. You can do a blast search if you want. Now let me type an example script, because we have our database set up and we have the programs installed. Query will be, I've got an example file here in the downloads called OTUs. Let me show it to you in the file explorer. Here in downloads, you see this is the file I'm going to test, and there's an option where you tell the program how many descriptions to write to the output file. I'll say 5. How many alignments, 5. How many threads of the computer to use. I'll put 3 because I have 4 threads, so 1 less than the total number of threads I have. Now output file, I want to call it otus.txt, and database, all you need to put there is NT, which is the base name of the database we downloaded. Because what you can see is that all our sequences in the database have NT as the base name. What you should normally do is, after adding the path, which we did through the control panel, you need to close the command prompt and restart it. If I press enter, I might get an error message. Oh, I didn't, so it worked. So it's running now, and it will produce an output file called otus.txt. So the Blast program just finished running, and I opened the file using cat otus. This was the command we issued. We used otus.fa as our input file, and we said we wanted 5 number of descriptions, 5 number of alignments, we used 3 threads. We called the output file otus.txt in the current folder, and we used NT as our database. Now, by typing cat otus.txt, we got this output. So our first sequence, OTU1, matched with pre-on-close punctatus and with E value of 0.0, identity level of 100%, which is fantastic. And got the same identity with the second hit. The third hit, I presume, let me look at the second alignment. Yeah, 100%, as you can see from here. The third hit also okay, that had 99%, which is still good. Fourth hit, fifth hit, 898. Now we are on the second OTU2 matched with Anatonchus tridentatus and E value of 0.0, the identity level of 99, and the second hit was Cumansus parvus, identity 99, expect value of 0.0. The third hit, uncultured nematode. Fourth hit, uncultured nematode. Now the third OTU matched with Longidorus Poisnecensis. Well, this is a very funny name. And the second hit, Longidorus macrosoma. Third hit, Longidorus cispiticola, Longidorus macrosoma, Longidorus helveticus, all with E values of 0.0. The first one with 99% identity, 99% identity for the second, 100% identity for cispiticola. Yeah, so this is what your output file would look like. The same information you would get from when you run it online. Of course, if we had left the number of descriptions and number of alignments at their default values, we would have produced much more alignments and much more descriptions.